Solving systems of equations. So what we want to do when we're solving systems of equations is that we solve for one variable, and then you solve for the other one after you do that. Solve for one variable, then solve for the other. Solve for the other. So example, if you solve for x, then solve for y. If you solve for y, then solve for x. So once you solve for the variable, then you write your solution for both variables. You write your solution as an ordered pair. So, and remember this is x and this is y. The last thing you should do is you should check to make sure you get that it is correct. You plug it into both equations. Let's try this first example, solve by substitution. So you have y equals 5 minus 2x at the bottom and 2x plus 3y equals 3. Substitution works really nicely if you have an isolated variable already. In this case, our y is isolated. So I'm going to put parentheses around the 5 minus 2x. That means at the top equation, I'm going to substitute that y, right? 5 minus 2x for that y value. So let me go ahead and substitute. 2x plus 3 times that y of 5 minus 2x equals 3, right? So I just took the 5 minus 2x and put it in there. When you substitute, you should only have one type of variable when you're done. So what that means is if you substitute and you happen to have an x and a y again, then something happened with your substitution. You probably substitute the wrong variable. So let's go ahead and solve. So this is just multiplying. We have to distribute that one. So we have 2x plus 15 minus 6x equals 3. Then we combine like terms. 2 minus 6x is negative 4x plus 15 equals 3. To solve for x, we subtract 15. So negative 4x equals negative 12. Then we divide by negative 4. So we know that x equals 3. So once we know that x equals 3, we take the 3 and plug it into one of the equations. It doesn't matter which one it is. So I'm going to go ahead and plug it into the bottom. It's just a matter of preference. I'm going to choose the bottom one because the y is already isolated. So y equals 5 minus 2 times x, which is our 3. So let's solve for y. Y equals 5 minus 6, or negative 1. That is our y value. So let's write that as an ordered pair. The x comes first, 3, negative 1. Now let's do a check just to make sure this is correct. So to do that, you just plug in this 3, negative 1 into both equations. So we have 2 times 3 plus 3 times negative 1, right? That's our y value. And then that equals 3. We want to see if that is true. So let's finish it out. So 2 times 3 is 6 minus 3 equals 3. Is that true? Yeah, 3 equals 3, so that is correct. So let's check the other one. So let's y. Our y is negative 1 equals 5 minus 2 times our x value, which is 3. We want to see if this is true. Negative 1 equals 5 minus 6. Negative 1 does, in fact, equal negative 1, right? Again, I just plugged in our x value, right? X is 3. And I plugged it in to my x value. And then the y value is negative 1, so I plugged it in for our negative 1 into the bottom equation, and that is true. So let's take a look at solving by elimination. When we solve by elimination, what we want to happen is that we want one variable to disappear. So for example, we want it to be the same variable, so if we choose x or we choose y. Notice here if we have x's, so let's just go with the x's right now. In order for that to disappear, to eliminate, is we need to have a positive 6x and a negative 6x. They need to be the same variable, the same coefficient with opposite signs. If, for example, we try to eliminate the y's, what does that need to be? Well, we have a negative 5y already, so what we need is a positive 5y, right? So whatever number is there, whatever variable is there, you just want it to have the same coefficient, but with opposite signs. So let's go ahead and try this out. So for this example, if I add it right now, right, let's try it. If I add it right now, I would get 12x minus 6y equals whatever it is right here. So as I add that, it doesn't disappear. So again, I need to make it opposite sign. So in order to make that happen, I'm going to multiply the bottom one by a negative, right? -1 or just a negative, and then you distribute. You distribute that negative through every single term. So look, if I do that, now I have negative 6x, negative times a negative is a positive 5y, and negative times a negative is a positive 27. So that is now our bottom equation. We just manipulated it a little bit, and it's okay because it's balanced. We did it to both sides in every single term. Let's go ahead and write this top one over again. 6x minus y equals negative 15. So now, if I add this together, notice that my x's disappears. Negative 6x plus 6x is 0. Then 5y minus y is a 4y, and 27 minus 15, well, that is 12. So now we can solve for y. Divide by 4, so therefore y equals 3. And then we can finish solving. We just plug it in. It doesn't matter which one you plug it in. I could plug it into this one here that I already manipulated. I could plug it into the original that's not changed, and I could plug it into here as well. So I'm going to go ahead and plug it into the top value to find our x value. So 6x minus 3 equals negative 15. So I add 3 to both sides. I get 6x equals negative 12. So divide by 6, x equals negative 2. Now, of course, you should double check the answer, but we know that the answer needs to be written as an ordered pair, so it should be negative 2, positive 3. Okay, that's the answer to that one. Now, solving by substitution, this last one, we have y equals 4x minus 3 and y equals 2x plus 7. So what you want to do to that is just set it equal to each other, because we know that y equals y, right? So that is true, y equals y. So we're going to take that 4x plus minus 3, for example, and then notice if we did the same thing that I did with the first problem, you just do this, right? So you're just setting it equal to each other. 4x minus 3 equals 2x plus 7. Then you solve, and so let's solve for x. So subtract 2x, you get 2x minus 3 equals 7. Add 3 to both sides. You get 2x equals 10 divided by 2, so we know that x equals 5. Then to find the other equation, just take the 5, plug it into one of the equations, doesn't matter which one, plug it into the top one. Y equals 4 times 5, and then minus 3. So y equals 20 minus 3, or y equals 17. So then to write the final answer, it's an ordered pair, x equals 5, 17. So I hope this helps. Thanks for watching.